already covered how to estimate three-dimensional solids volumes using MRAM or Riemann sums, we can now use integration for the same purpose. Basically, to find a solid's volume over a given interval a to b, one must compile the infinite series of two-dimensional planes that make up the solid. For this solid, the cross-sections at each x value between a and b have an area described by the continuous function a of x. So here's a picture of such a solid. And it's from a to b, and at this x value, the area of the cross-section of the solid is described by the function a of x. Having trouble pointing my finger right there. Alright, so let's apply this kind of general principle for this solid that we have here. So the first thing we need to do is figure out what a of x is. In other words, we need to figure out what function will give us the area at any given cross-section in this solid. And for this solid, it's a cone. You can see that the line that is the top of the cone is the function y equals x, and we know that since it's a series of circles and the equation for the area of a circle is pi r squared, for any x value the radius is going to be simply x or y since they're identical, so for each circle it's going to be pi times x squared, and evaluated from 0 to 3. So we move from this general equation, and then we can plug in what a of x is, pi x squared, from 0 to 3, and then we follow the standard procedure for finding integrals. We take the antiderivative of pi x squared, we get x cubed over 3, and pull out the pi right there from 0 to 3, and then we get an answer of 28.2, or 9 pi. So next we're going to look at a little bit more complicated method for finding more complicated three-dimensional figures. And we're going to look at the washer method. And the purpose of the washer method is to find the volume of a shape where instead of the cross-sections being nice circles, which are easy to work with, they're actually washers, which means they're circles with a circle missing in the middle. What we're going to do is we're going to use right here the shape enclosed by the lines y equals 3, y equals x, and the y-axis. So it forms a triangle, and we're going to rotate that around the x-axis. And it's a little bit hard to visualize, but the shape that's going to create is going to be this one right here. So basically it's going to be a cylinder with a cone-shaped cavity removed. As I said, the purpose is to find shapes, or to integrate using shapes that are washers. So we're going to have to do some subtraction. Volume equals integral from a to b of the top area minus the bottom area, so pi times the large radius, or times the large radius squared minus pi times the small radius squared. And so evaluated for this, it's going to be from 0 to 3, pi times 3 squared, since that's the large radius, minus pi times x squared, since that's the smaller radius. And you can simplify that by right here, from 0 to 3, pi times 9 minus x squared. And so when we do all the work, it comes out as, you can pull out the pi, and then you get the antiderivative is 9x minus x cubed over 3, evaluated from 0 to 3, so the answer is 18 pi. So in this problem, what you're going to do is find the volume of the figure determined by the shape enclosed by y equals x, y equals negative x squared plus 2, and the y-axis revolved about the x-axis. So that's going to be this shaded shape that I've drawn right here, and it's going to be revolved about the x-axis to get a similar three-dimensional figure to the one that we just talked about a moment ago. So go ahead and just do this, and you can pause the video now while you're working, and then I'll have the answer and the explanation for you in a moment. So as we know, the volume, when you're using the Washer cross-section method, is the integral from a to b of pi times the big radius minus pi times the little radius dx. So for this, it's going to be from 0 to 1, since they intersect at 1, which is kind of coincidentally really convenient. But it's going to be pi times the quantity negative x squared plus 2 squared minus pi times x squared dx. And it gets pretty messy, so I actually just FOILed out the here into the antiderivative, so you can pull out the pi, and then you get the quantity x to the 5th over 5 minus 4x cubed over 3 plus 4x minus the quantity x cubed over 3, evaluated from 0 to 1, and the answer is going to end up being 7.95. Although the Washer method is definitely the best in some circumstances, there are other methods that are a lot better suited for certain shapes and certain equations. For example, the shell method is a really helpful one and a really important tool in calculus, because if you wanted to find this shape, or I'm sorry, the volume of this shape revolved around the y-axis right here, through the Washer method, it'd be really difficult because it's really hard to take on this equation in terms of y, and it just get really messy. So instead of using the Washer method, you can use something called the shell method, where one creates an infinite series of shells from this shape, and because the shells can be unraveled into rectangles and you can recognize the rectangle's dimensions, you can make an equation from it that makes integrating the shape pretty easy. So this is the equation. It's 2 pi times the shell radius times the shell height. In this case, the shell radius is just from here to there, and the shell height is just the height of it up as it follows the equation, and that's either dy or dx depending on what you're taking it in terms of. So for this specific shape, it's from 0 to 3, 2 pi times x, which is the shell radius, times 3x minus x squared, which is the shell height, dx. And through the shell method, we can more easily find that it's 42.4. So for the last homework problem, what you're going to be doing is finding the volume of the 3D figure that is this space that's enclosed by the x-axis, the y-axis, and the equation y equals negative x squared plus 4 revolved about the y-axis. And remember that the equation for the shell method is volume equals the integral from a to b of 2 pi times the shell radius times the shell height. So here's the answer to the second homework problem. Here's the shape that we revolved around the y-axis, and we know that volume equals the integral from a to b of 2 pi times the radius of the shell times the height of the shell, dx. And so for this specific shape, it's from 0 to 2, 2 pi times x, which is the radius of this, times negative x squared plus 4, which is the height of the shell, dx. And the answer is 25.13.